All right, section 4.4 is on congruency transformations. The learning target for this lesson is I can identify congruent figures and describe congruency transformations. So let's take a look at a few important information we need to know here. Congruent figures are figures that are the same size, okay, and the same shape. Okay, all corresponding sides and angles are congruent. Okay, rigid motions, or we also call them congruency transformations. Okay, it's when you perform one or a few transformations, right? And then you get the same image, okay, figure. So congruent rigid motions, they maintain size, okay, and shape from the pre-image to the image, okay? The pre-image and the image are congruent, always congruent. And the three rigid motions that we've discussed, right, were translations, reflections, and rotations. Okay, so now how do we use this information? Well, basically what we're going to be doing is we're going to be identifying two figures that are congruent, right, on the coordinate plane. And in order for us to prove that they are congruent, we have to find a series of transformations, right, that takes one onto the other. Okay, so first let's take a look at this side right here, the left side. And it says identify any congruent figures in the coordinate plane and explain. Okay, so just by looking at it, right, I can see, okay, ABC, this triangle ABC looks like it's congruent to DEF. Okay, just by the visual. Okay, what else? This one right here doesn't look like it's congruent to anything. It's a little bit longer than this one. This one right here, this triangle and this triangle, they look pretty similar right there. And this one here with this one here, they look like they are congruent. Okay, so let's take a look. I can say that triangle EDF is congruent to triangle BAC. Okay, because look, if I take this, if you draw the line right here and right here, I can see that this was a rotation of 90 degrees. Okay, so so rotate triangle the EDF 90 degrees, and we're going clockwise. Okay, clockwise. Okay, so now we've shown that they are congruent. Okay, let's take a look at the rectangles here. So we can say that rectangle IJGH is congruent to rectangle QRNP. Okay, because look, we could just slide it down, right, and place G on top of N, H on top of P, J on top of R, and I on top of Q. Okay, so this would be a translation. 1, 2, 3, 4, 5, 6, 6 units down. All right, and then the last one, these two triangles, right? So triangle LMK is congruent to triangle TUS. And then notice, it looks like this has been flipped, right, across the y-axis. So it's been flipped, right? So this is a reflection across, oops, y-axis. Sorry, I misspelled that. Okay, across the y-axis. And you can't see what I wrote. There you go. Okay, so I would like for you to do this one right here, okay? This one. And you're doing exactly the same thing I did. You're identifying the congruent figures and you're explaining, right? You're writing the congruency statement and why do you say they are congruent? All right, so let's take a look at the next problem here. This one, I want to describe a congruency transformation that maps quadrilateral ABCD to quadrilateral EFGH. Okay, so notice this one here is going to be your pre-image, okay? And this one is your image. So it's important to identify where is your starting point and where is your ending point. Now, there will be more than one options, okay? There will be many options. There could be many options, okay, to do this. So if you see one that's different than the one I'm doing, right? Yes, it's possible. Okay, so here, if I look at ABCD, right, I can take that and I can translate it 5 units to the left. So let's see what happens here. 1, 2, 3, 4, 5. Here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so this would be A prime, B prime, C prime, and D prime. Okay, and now, look, now I can just flip this across the x-axis. Right there. If I flip it, right, I get this image. B maps to H, C prime maps to 1, 2, 3, 1, 2, 3 to E, D prime maps to 1, 2, 3, 1, 2, 3 to F, and then A prime maps to G. Okay, so how do we explain that? Okay, so we translate quadrilateral A, B, C, D, 5 units left, okay, to create quadrilateral A prime, B prime, C prime, D prime, okay, then reflect quadrilateral A prime, B prime, C prime, D prime about x-axis to create quadrilateral G, G, H, E, F. Notice that I have to match, okay? So A prime matches G, so that has to be in the same position. B prime matches H. B prime and H has to be in the same position when you name it, okay? C prime matches E prime, so C prime is the third letter, E is the third letter. And then D prime, right, is the fourth letter, it matches F, so that has to be the fourth letter, okay? All right, so now this next one, I want you to do it also to find a series, a rigid motion, okay, that takes triangle JKL to triangle MNP.